In this video, we're going to dive into the configuration and operation of the Isovalent Load Balancer, the new software-defined load balancer announced at Cisco Live US San Diego. From here, I'm going to jump through a couple of specifics around the ILB itself, its architecture, how we configure it, how we check its health, and then we're actually going to use it as a proper load balancer and configure a couple of different services, starting really simple and then going more advanced. So maybe configurations such as TLS Pass Through, weighted backends, and yeah, let's get going with that straight away. So in my environment, I've already deployed the load balancer itself. The load balancer is configured via a Kubernetes control plane, so you're going to see some very similar concepts in terms of interacting with it that you would with Kubernetes. First, I'm going to use the Cilium LB status command, very similar to operating with Cilium itself, because the ILB is based on Cilium. And we can see today we've got 2 T1 nodes and 2 T2 nodes. And essentially from an architectural point of view, the differentiation between those nodes is the front-end nodes provide all of the load balance capabilities, L3, L4 type capabilities, and then the L2 nodes are where all the smart things really happen. So when we start to think about application specific features, so TLS Pass Through, weighted backends, merging traffic across and so forth, into our actual applications and handling all of that. So you can scale those nodes independently going forward. What does that look like in our lab today? So I'm going to just quickly put up an image for you to see. You can see that on the right hand side, we've got our applications that we're going to be load balancing to. On our left hand side, we've got the external infrastructure. So we've got a router that we're going to be using BGP, so we can advertise our virtual IP addresses to the network. We've got our external client that we're going to be using to connect via the load balancer to our web applications and test some of these features. We've got the kubectl command I'm going to be running from my control plane, which connects into those nodes. And in the middle there, you can see the Isovalent Load Balancer itself. So we've got those T1 nodes that we were talking about in the middle, and then in the middle on the left, and then on the right hand side, we've got the T2 nodes, which is where we're going to be using things like Envoy and so forth for all that layer 7 capability. Now that our load balancer is up and running, let's start diving in and configuring it. Load balancer configurations are stored into multiple namespaces, which gives us the idea and concept of multi-tenancy as well. So a virtual IP address will be assigned, and then we'll assign back our backends and the configuration of those applications. So I'm going to create something called the LB demo as a namespace. And again, looks very similar to the concept of a Kubernetes namespace from that point of view. It's just a metadata way of keeping all of those configurations together. I'm going to start by adding a virtual IP address. So very simple, deploying it into my namespace, deploying its name, and then we're requesting a particular address, and we're going to see where that address comes from later on as well. For those of you already using Cilium today, you'll be kind of aware of some of those concepts. Going to apply there, and then if I get service, you're going to see as well that we can see the service that is type load balancer. We've got the IP address. That's a cluster IP internally, but the actual external IP is still pending at the moment because it's not being provided to us via the IPAM inside of the platform. You'll, if I inspect that service in a little bit more detail, we'll notice a couple of service annotations that have been added at metadata level. So first and foremost, we've got the IP address that we specified as part of that request. We've got a sharing key, so that enables the application service to share its IP with the virtual IP service itself. And then we've got the no advertisement true, so that prevents the virtual IP itself from being advertised by BGP. Instead, each services are going to be advertised individually as we start to configure that as well. You'll also see an owner reference section that's provided as well, and that essentially is just tying that back to our VIP address going forward. So next, start setting up the service to serve an application that runs on our backends itself, so our web servers. So I've got a manifest here, which is our LB service. you can see straight away I'm giving it a name as you'd expect, but also then straight away we're referencing our virtual IP address that we want to use to be tied to that service. Then we're setting up what port to serve out on, and then our application specifics as well. So first and foremost, I'm just going to do really simple HTTP proxy, and we're going to go to a single backend reference. So that reference is going to be another manifest, which has all the details in of our web servers that we're going to contact, and that's called demo backend. Before we apply that, actually, one of the things I want to explain as well, using one of my favorite tools, the kubectls explain tool, is looking at the application specification. We can also start to see some of the other fields that are supported. We can do HTTP proxy, HTTPS, TCP, TLS Pass Through, TLS proxy, and UDP proxy as well. So a lot of configurability in terms of the applications and types and specifics that we support there as well, and that will grow in the future as well. And we'll look at a little bit more of some of those advanced configurations as we go through this video. So I'm going to apply that manifest, and then I'm just going to clear down my screen here to make it easier. Let's get the information that's been deployed. So you can see here we now have a demo service, but straight away we've got a condition, the status condition not met, meaning that this is not ready to serve out our application for some reason. So let's see why that is. Again, if I were doing a describe here on that service to get more details, we can see that the backends don't exist. So I've referenced a manifest that is not yet been applied. And then at the bottom, we can also see that the IP address is still pending as well as part of that load balancer configuration. So the VIP pair has come up. We told it what IP address to use, but it's actually not been distributed by the IPAM method yet. So let's first and foremost configure those backends. So like all the demos, I've already got this ready. So another manifest, the kind is LB backend pool. We've given it a name. In the backends, I'm specifying the health check. So the health check will be every 30 seconds, trying a particular path of those backends to make sure that they're available. And then I specified one backend with its IP address and which port that is on as well. And then later on, we'll start to kind of configure that with a couple of advanced options as well. So let's apply that. We're going to look at the resource itself using the describe command, and again we can see stated at the bottom here that the backend pool is valid and accepted, and it also means that the health check is passing as well. We would see errors there if there's any of the nodes that were added to that backend that would have problems. If I look at the service state again, we can still see we've got that one IP address problem that is still pending. However, all backends are compatible and available and exist, so that's fantastic. So now let's look at configuring that IP address. So we're going to be using a standard Cilium load balancer IP pool because we're taking all of that greatness of Cilium to help us with the features for the software-defined load balancer. So let's look at our pool. Very simple, we're just giving it a particular CIDR block, and of course earlier on when we specified an IP address to use, it was part of that CIDR block as well. So we're going to apply that, and if we check the service again, we can now see that the status has changed to OK, and that the IP address is showing. Let's see the status of the load balancer overall. So we can see now we've got the service that has come up in the particular namespace, the VIP that's been added, it's a type of HTTP proxy, the mode, so we're going from T1 to T2 because we're using some of the layer 7 features there for that HTTP piece. We can see that we've got degraded BGP routes, and then ultimately at the bottom here, the status is offline. Just see it concatenated a little bit there and wrapped in my terminal, but essentially that's what's going on. So let's look at how we fix that going forward. So with the BGP configuration, again, this comes from Cilium. We've got an FRR router in my demo lab so that I can connect to that for a pairing point of view. So we're going to have a quick look at that BGP configuration. If you've ever used Cilium before, a lot of this should look very similar. So we're going to set up a BGP cluster configuration. We're going to give it a name in an instance. We're going to tell it what the external peer is of that FRR. We're going to set the peer configuration, so what is it we're actually advertising out. And then if we go down, we've got our advertisement services itself. So we're saying advertise all services, type of load balancer IP addresses from there. And then the selector, essentially we're just putting some dummy values in there so it advertises all load balancer services going forward. But again, we could be very hyper specific with that as well. And then because we're using the Isovalent Enterprise distribution of Cilium, it allows to also access those enterprise features from Cilium for BGP as well. So we're using BFD here, which helps with that connectivity point of view going forward. Okay, so when I apply that config, I can use Cilium commands again from the BGP. So we're going to use BGP peers. We can see that that's established. We've got an advertisement going on. And that will start to count up. And then if I can also look at the routes, and we can see that the next hops have been set in place as well. And then finally, if I run that status command, we can now see that everything's online, and we can even see that the BGP peers and routes have gone to OK as well. So now let's test this very basic service that we have up and running. I'm going to go to my client's machine, my second tab there, and I'm just going to curl the IP address that we set up as the load balancer IP address. And we can see we get a response from my red backend, and we'll look at that into a little bit more detail. And now I'm just going to go back in, I'm going to edit that backend pool, I'm going to add a few more backends in, and we'll see how that changes. So I open up my files, go to my backend pool, and we'll replace that there. So I've added 3 additional web servers to terminate against. We're going to reapply this back on my control plane machine. I'm going to check my status again. We can now see that the backend pool here has changed to 4 from 1. And now I'm just going to test that again. I'm just going to run a quick script to do that. And now we can see we're cycling through different nodes or instance nodes there. And I've used colors of the rainbow to signify those different nodes that we're connecting to. Okay, let's look at more HTTP proxy features. So far, we've just set up a very basic HTTP service and accessed our lab using its virtual IP address. But typically, we wouldn't be doing that in a real-world production environment. We'd be using some sort of Vhost support so that we can access our services using a DNS name instead of IP services. So we're going to start to fix that in our environment and then make this a little more like production setup. So I'm going to click on my editor here. We're going to go to my LB service. And I'm just going to rip and replace this. And now I'm going to match on host names for that request coming back in as part of that route, which means when we try to access it on the IP address, it's going to stop working. However, if I reference it on the correct vhost DNS name, it will pass that information through. If I go to my control plane machine, I'm going to apply that change. And then on my terminal client, if you remember, a second ago we tried on the IP address and it works, but now we're going to get a 404 not found from the load balancer because there's nothing that meets that address is published, but there's nothing that meets that specification. But if I pass that with using the resolve command inside of curl, so I don't have to mess around with my host file locally, we can see that now this works. As I mentioned earlier, we're going to look at some more advanced specifics, so let's have a look at some weighted backends. So I'm going to go back into my editor. I'm going to look at my backend pool, and I'm just going to update these backends to include weights for them. So very simple, just weights for these. I'm going to go back to my control plane, and I'm going to add that configuration again. And then on my terminal, we're going to test that this still works. We're going to pass the header of content type application JSON. And then we're going to pipe that output as well, just so we can see it. So we can see one of the things here is we actually get that instance name. That's where we're getting that color of the rainbow from, so we can specify where it is. And then I'm going to run another command now just to hit this a number of times, and then we're going to count the different instance names that turns up. And then what we should see is a preference. So roughly we've got 10 there, we've got 18, we've got 30 against yellow and 42 against purple as well, which kind of roughly go against those simple weights that I put in going forward. One of the other features that we typically see with load balancers is this concept of persistent backend. So for some applications, you need to be consistently connected to the web service you're terminating against for stateful data sessions, for example. So again, the ILB supports that type of configuration. So we're just going to look at that method to make that happen. I'm going to go back into my editor. We're going to go back to the service itself. And then at this bottom section here, I'm just going to add in persistent backend sticky, which means I'm going to be routed to the same one, and then I'll try and hit that multiple times, and we'll see that it always terminates against that same backend unless it was available for some reason. So we'll update on the control plane. And then I'm going to check that service again. We're going to see that conditions are not met because I've made a particular configuration here, which now requires something else. So let's see why that is. So I'm going to run that describe command against the service, and straight away we can see reasons. We've got incompatible backends, and the message there above that is configured persistent backend, which change we've made, but we don't have the algorithm set up that allows for this as well. So let's fix that. So we're going to go back into our backend pool, and we're just going to add in the load balancing algorithm as consistent hashing. Go back to my control plane, clear that down. We're now going to update the backend pool as well. We're now going to check that service again, so we can see that it's okay again, so the conditions are all met. And then on my client, I'm going to run a quick script, which basically does the same as that single request I made earlier, but we're going to add some counts and sorts on there as well. And now we can see we go 100% to the yellow backend. And the reason for that is because that was the highest weight, because we've still got the weights added as well. So we're always going to hit yellow first unless it's unavailable. And because it's persistent, it's always going to go to that yellow one unless it's unavailable. Okay, so that was all HTTP traffic. One of the reasons why a lot of people use load balancers though is to deal with HTTP traffic and certificates and so forth as well. And there's always two methods with that. So let's dive into that in our last section. So adding security into our load balancer is still really simple. As you've seen before, configuring this load balancer, it's done through manifest, and we're just going to carry on doing the same type of thing, but use some more of those advanced features. So we're now going to configure that LB service to listen on port 443 and serve the backends with HTTPS. So we're going to reuse the same virtual IP address and the same backend pool to do this. So I'm going to go to my control plane, which I'm already on. I'm going to view that file. So I'm going to set up a new service. In that new service, however, we're going to fix that. We're going to basically create a second service that uses that same VIP. I've noticed here I've got a quick issue. I've misnamed my VIP file, so we're going to fix that very quickly as well. So we're going to go here to my files. I'm going to add that in. But again, this is kind of a really good show and tell because we can see very quickly like what's going on and what the problems are and how easy it is to fix these things in an environment. Just going back through the rest of this file, we're going to port 43 as I mentioned. We've got our HTTPS proxy, which then allows us our additional configuration to things like TLS configuration. We're going to reference a certificate that's being created. We're going to match on that root name that we saw earlier. And again, we're going to use that same backend reference. So I'm just going to quickly run that YQ command again. I'm going to see here, I've just fixed that. And we're going to apply that manifest. And then if I close down, we're going to describe that service. And once again, we have a problem with that service. And that's because I'd yet to create the TLS secret, or that secret configuration in the background with those TLS certificate added. So let's fix that now. So we're going to create a secret. It's in that same namespace. And then if I describe the service again, we can see that everything is good. We'll clear that down. I'm going to go to my terminal on my client, and then I'm going to curl that name. I'm going to use the certificate as well. And we can see here I've hit the purple back end to get access to there. So now we're doing TLS termination at the load balancer side, and then passing that traffic unencrypted to the backend pool at the moment. That's fantastic, but again, that doesn't always work for every application. A lot of times we see the need for what's called TLS Pass Through. So the idea here is the application itself that you terminate against is providing the security or has security methods in place. So the load balancer just needs to transit through all of the data and information back and forth to that point. So we're going to go to our control plane. We're going to set up a new set of services for this to do this rather than modify our existing. So I'm going to create a new namespace now, which is called Secure Web Demo. And then we're going to create a new service inside of there. So if we check our TLS Pass Through service configuration, I've got a new name on a new service and a new namespace. We've got a secure web service, a secure web VIP, so we're going to use a new virtual IP address. We've got a new host name to terminate against, and then we've got a new backend reference as well. But here you can see that we're using port 80 for this. We're using normal kind of traffic ports and then passing that through as TLS, taking that security information, pass it through to those backends. So let's have a look at our backend pool. Very similar to earlier, we've got a set health check there. We've got 2 backends that we'll go into as well. Clear that down. And we're going to apply all those manifests inside, and it's just creating a VIP as well. VIP is the exact same as we saw earlier in the demo. If I go back to my terminal on the client, we're going to query the secure web service. And now we can see, again, we've got a web secure server. It's passing through and everything works as we expect. And that wraps it for today's session. Very quick overview of how to configure and operate the Isovalent Load Balancer. This is just a small number of features that we support out of the box today. Visit isovalent.com for our labs page. So you can go to labs, all Isovalent labs, and then you'll see there getting started with the Isovalent Load Balancer, which takes you through a more detailed set of instructions and challengings so you can fully appreciate all the features. And thank you very much for joining us today.